Hello, everyone. Good afternoon, dear authors and invited guests. Welcome to Technical Session 7A. Myself, Karthik Bharadwaj, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Solistic LLP, it's my great pleasure to welcome you to the third World Conference on Information System for Business Management, ISBM 2024, Bangkok, Thailand. The third edition of the conference is being organized in a hybrid mode. The physical event is organized today in Bangkok, Thailand, and the virtual event is being held through Zoom today and tomorrow, that is 12th and 13th of September 2024. I hope you will enjoy the knowledgeable and interactive session throughout the day. In this session, we have 6 presentations, and each presenter will be given 12 minutes for presentation and 3 minutes for question answer round. On 10 minutes, I will raise a gentle reminder. There is another request to all the participants to stay connected with us till the closing remark. If you have any query, so you can write it to me in the chat box. So just before we get started, I would like to introduce you with today's session chair, Dr. Prince Sukriti. Dr. Pren is presently working as a professor at Finn School of Business and Tourism, Bangkok, Thailand, with a doctorate in business and specialization in blockchain, IoT, and AI. Pren offers more than 20 years of combined executive and academic experience. His expertise lies in cultivating strategies, partnerships, driving educational excellence, and steering technologies toward innovation. I request Sir to kindly motivate our participants.
Okay, sure. Actually, I'm sorry for this, but I haven't got the list of the name. So Patrick, can you start first? Can you just tell who will start first? Patrick,
Thank you, sir.
Yeah. Okay.
Thank you, sir. Now I would like to introduce you with the next session chair, Dr. Nimisha Patel. Dr. Nimisha Patel had 19 years of experience in teaching in the field of computer science and engineering, computer engineering and information technology. She is currently working as a professor, HOD CE, CSC, ICT, SAL Institute of Technology Engineering Research, SAL Education, Ahmedabad, India. She has 51 research papers in various conferences and journals of national and international repute with Scopus, ECI, UGC indexing. She has delivered expert talks and also acted as a session chair and reviewer for many conferences. Her area of domain is cloud computing, networking, information security, and parallel programming. I request ma'am to kindly motivate our participants.
Thank you, sir, for a warm welcome. First of all, I will congratulate all the participants for presenting the paper today, remaining the present for the presenting the paper, and my best wishes for your presentation. Thank you.
Thank you, ma'am, for such kind words. Now, I would like to start with the session. For the first presentation, I would like to call Mathili for the paper title, Clearing Faces in Blurred Surveillance Images, Evaluating the Effectiveness of Deliberate Blur Simulation for Face Detection. I request the presenter to kindly proceed with their presentation.
Yes, thank you so much, Patrick. Can I?
Ma'am, you can proceed with your presentation.
Yeah. Hopefully, I am visible.
Yes, ma'am.
It is visible, but please make a presentation mode.
Yes, please. Good afternoon, everyone. Myself, Maithili Madikar, and I'll be presenting on my paper titled Clearing Faces in Blurred Surveillance Images, Evaluating the Effectiveness of Deliberate Blur and Simulation for Face Detection. My team members are myself, Maithili, our Professor Pushpavati Kanaje, under which we are doing the entire research work. Other team members are Sairaj, Kranti, and Ruturaj. So let's start by addressing a common challenge many of us face, that is blurry face images. These blur often arise from few key issues like motion, low light, or poor focus. Whether it's a security camera capturing a fleet movement or a personal photo taken under less than identical conditions, blurry image can significantly hamper our ability to clearly understand and identify the individual that we have been storing in many photos. So the motivation behind this project was to solve this problem. As we know that, okay, let's consider first the critical role that clear face images play in real life scenarios. In security settings, for example, the ability to clearly identify individual can be crucial for preventing and solving crimes. Security cameras and surveillance systems rely on clear images to provide accurate evidence and public safety. Fortunately, in modern, we do have many modern tools that allow us to recover and enhance image details efficiently, but we tried to create a solution that combines many of the algorithms and software together to build an enhanced security system. So the overview of our project aims to tackle the issue of blurry face images by integrating CNN and MTCNN concept. By combining these two advanced technology, we can effectively detect faces and address the blur issues. For this, we have almost referred 30 papers, out of which 19 we have considered for this report. Our main objective is face deblurring, detection for criminal identification, and which will be useful for evaluation and validation. Now, the entire architecture that I would like to explain how our project we are proceeding with. Now, first we will get the image, that is image acquisition. In this step, the image would be obtained, which may be blurred or degraded image. Next, we are taking into blur model identification. In this step, the system tries to understand the type of blur. The blur, as we all know, the blur caused to an image can be of multiple types. For example, motion blur that can be caused because of relative movement between the camera and the object. Deep focus blur, which happens when object is out of focus. To identify which kind of blur the image has, this step we have done. Then next we have PSF. Now PSF, point spread function estimation. This is a mathematical model that describes how a point source like a pixel spread that is blurs out in image due to blur. This function is estimated over here. We have used this PSF function over here that would be that is very crucial for our next step, that is LR algorithm. LR algorithm is nothing but Lucy Richardson algorithm, a deblurring algorithm used to restore the image based on the PSF that we have obtained in the previous step. Now to recover this sharp image by we use LR algorithm, which iteratively iteratively runs and tries to get the image which has like the most or the least amount of error or noise, we can say. For after that, it do have the sub processes in which we are trying to get more and more clearer image. As I said, this is iteratively done, so these steps would run completely till we get the more clear and precise image. After this, we are using more algorithms and topics like for getting more clearer image. Uh, the regularization and post processing, these are the additional techniques are applied to refine the deblur image and suppress the noise to just to enhance the output. Now, once all these steps are done, we will get the clear face image, which will be interpreted. Now, our main motive was that once we get the clear set image, we can compare it with the any criminal database or a database that police has, so that it can be easier for them to trace the criminal activities and would solve problem in efficient way. So so I would like to and summarize this that what there are four main steps we are doing. First is image acquisition, that we will collect the images that are blurry or do have certain distortion. Second is we will identify the blur that we were doing in the blur model identification step, that is second step. And third is the deblurring process. And once all this is done, we will detect the face, uh, which will tell like accurate results. Now, as our system, we are in developing stage, there are limitations that we are facing. First is image quality. If image quality is too much bad or degraded, it's difficult to restore it And this is also caused due to low resolution or poor quality images, which certainly reduce the effectiveness. And this is one like challenge that we are currently facing. Apart from that, the motion blur is also one of the limitation of this. Like if motion blur is caused to certain level, it can be regenerated, but if it is above that level, then it becomes tough for us to regenerate and regain that original image. Then again, extreme light conditions is also one of the limitations, as light distorts can cause the image to be more different than its actual version. Then the significant variation we are facing in the face angle, like if the person, like everyone looks, if we are seeing their picture from the front angle, they look different and as compared to a different angle. So this become difficult for the face detection part. So these are all the limitations, and we hope that we will able to overcome this all. And thank you for listening, and thank you so much.
Thank you, ma'am. Respected session chair, sir and ma'am, do you have any questions?
Hello,
Yes, ma'am.
Michael. Very good work done. I would just like to know that how much accuracy you have achieved.
Ma'am, yes, ma'am. So initially, the first model that we generated was having accuracy of 94%, but the issue that we faced was if number of images and data set is increased, then our application is becoming little slow. So we are now working over again to improve accuracy. Now we are using APIs and library like get frontal face detector, that is an API present in dlib library. So yes, ma'am.
Thank you, ma'am. Sir, do you have any questions?
Yeah, we don't have yet. Okay.
Okay, sir. Now we are moving towards the next presentation. For the next presentation, I would like to call Gotsa Bakin for the paper title Detecting Software Detects in Generated Python Code with Applied Natural Language Processing Optimized by Modified Mechatronics. I request the presenter to kindly proceed with their presentation.
Okay. Is everything is okay? You see my presentation?
Yes, ma'am, we are able to see your presentation.
Yeah, thank you so much. Well, first of all, I would like to say hello to everybody. And my name is Jelena Kaljevic. I'm the part of the team who did this exploring this paperwork. The name is Detecting Software Defects in General Python Code with Applied Natural Language Processing Optimized by Modified Meta-Heuristic. My colleagues and I did this paperwork, and they are John Filipose, Willow, Sarama John Willow, Luka Jovanovic, Miodrag Živkovic, Joseph Mani, Miloš Antonijević, myself, Marina Milovanovic, and our professor Nebojša Bačani. Well, first of all, the rapid progress in the technology and information sciences, along with the increasing demand for automation, have created a growing need for code that defines operation and tasks. And for example, in the information age, software plays an increasingly important role in everyday life. As we mentioned in our paperwork, from controlling safety system in elevators to traffic and even vehicle systems, software plays a fundamental role. Software is not without errors. unexpected scenarios, breaks in operation, loss of power, differences in hardware, and even soft errors caused by external factors can be caused multifunctions. So to ensure through and effective testing across diverse application field, software testers must consistently and have a new knowledge and adapt to fast evolving circumstances. So by taking a data-driven approach, advanced artificial intelligence and machine learning algorithms could potentially be leveraged to tackle a portion of defect detection adequately. So this work seeks to explore the potential of leveraging NLP, natural language processing NLP, to detect Python code whitening based on specification. The extreme gradient boosting algorithm, XGBoost, is combined with the bidirectional encoder representation from transformers, BERT, like BERT, encoder to detect faults in a semi-synthetic code based on mostly basic Python problems. So these are actually things that are the most popular and very, very important for this research. The scientific contribution of this work are summarized in a few sentences. First of all, was a proposal for a system based on NLP for software fault detection. The second one is an introduction to meta-heuristic based approach for tuning the hypermeters of XGBoost classifier. And the third one is an enhanced version of meta-heuristic optimizer for that leverages the outstanding performance of the original algorithm. So for example, BERT, as you can see, BERT is actually some has become popular in NLP research, and it's as you can see, a relatively new language presentation framework. The use of BERT has become popular, and embedding allows models to capture the enhance of corpus of text, such as source code, format suitable for the use machine learning algorithms, and so on. So additionally, BERT uses bidirectional data flow, thus rather than relying just on single word analysis. The final thing is that the techniques from masked language models are used to train BERT model. The main concept is to conceal a word from the text, so that the model can predict a random word from it, which aids in the model's learning of linguistic structures and patterns. So these are some things they are important about BERT, but for example, XGBoost stands out from other machine learning methods due to its high performance. It is composed of numbers Vickers predictors combined to create an accurate model. So, for example, the objective function of XGBoost is provided in our paper. And for example, as you can see, XGBoots have this kind of calculations. For example, for the t instance, is the objective functions is represented by this formula, this equation, and what we actually do, how we use these two methods to actually connect and do the best thing for our search. The most important thing is also VNS, variable neighborhood search. For example, the basic VNS algorithm consists on several stages. During the improvement protocols, the algorithm explores local neighborhoods. We call it N from X, and a better solution is selected, donated X, and that solution location are updated. The two most common strategies are the first improvement and best improvement strategies. So as we can see, we try to do some modification, and we did it. The base from the VNS algorithm demonstrates decent algorithms. However, by design, it integrates well with advanced techniques to formulate improved optimizers for that. And for example, the adaptive approach is incorporated with control parameter. So initially, this parameter is set to the value of the 0.96 in the gradiency by 0.04 in each iteration to encourage exploration in early and exploration in better iteration. So as you can see, once optimization begins and the start of each iteration, a random number is generated in the range from 0 to 1. Should be actually generated, the value exceed the current value, the worst performing agent is removed from the population and replaced by a newly initialized solutions. So this is how that experimental setup is shown in this algorithm. For example, the data set consists of programming problem descriptions, proposed solutions, and set a test to determine the availability of the solution. So after that, we did this experimental setup, and for example, there is a lot of actually simulation outcomes. First of all, we have some data set which we use consists of programming problem descriptions, and we switch it with combining boost and XG boosts. So these are actually steps how we did this research, and the results are more than better. Actually, the outcomes in terms of the objective function are presented in table 2, as you can see. While several optimizers managed to match the best performing model, the newly introduced optimizer consistently achieved the best results, even in the worst mean and median exhaustion. Additionally, the introduced algorithm demonstrates a remarkable stability. Compressions of the optimizer stability are illustrated in figure 1. Oh, I'm sorry. From this algorithm, and for example, this table 4 is I'm actually looking at the time. I'm out of time more, so I can explain everything from that. But as the evidence, the introduced optimizer avoid local optima that hidens the performance of other optimizers, This figure 4 and table 4 is more important for this part of this paper, and further details of classification performance details on the best performing model and provided in ROC, as you can see, and what is the main thing that I have to point? The rapid development of technology and the information sciences, as well as increased demand for automation, has led to an ever increasing demand. So software projects often rely on dedicated testing teams and long procedures to prepare and implement processes and operation into a product. So this work seeks to explore the potential of NLP in combination with classifier algorithms for tackling software defects detection from Python source code, and actually a semi-synthetic data set is explored and the classifier is applied for fault detection. So further work I hope, will explore further tackling the challenges. This work introduced a modified version of the VNS algorithm, and actually it tackles the demands of optimization in this research, and outcomes suggest that the use of NLP for code errors detection might be a viable approach, with the best model exceeding 99.7% accuracy. So that is actually our conclusion for the end.
Thank you, ma'am. Session chairs, do you have any questions?
Hello?
Yes, ma'am.
Yeah, I just wanted to know that whatever the data set you have used, what is the size of that data set? Hello?
I'm sorry. Could you repeat? I can hear the best.
So,
Yeah.
whatever the data set you have used, I just wanted to know that what is the size of the data set?
Yes. Actually, thank you, ma'am. This work actually we did it for not so long time, but detailed metrics for the best performing models actually generated by each optimizer are actually the several optimizers managed to match performance in the best case exhaustion. So the analysis and comparing these two things are essential to support research for some kind of optimal problem optimizer pairings.
Okay. Thank you.
Okay.
Okay, thank you.
Okay. And for the further research for this one, after this, what you plan to do next after you use this one, and how can it use for the application in the future as well?
Yes, actually, there is a lot of plans for future works. First of all, as I said, is to explore further tacklings, and we will try to do more high percentage of this occurrency. For example, from this paper, it was very high, 99.7. We will try to do it best and to combine with some other algorithms, but these are actually some lab things to which are actually in process. So I hope in next conference we will be better and with new ideas for doing the best job from this area.
Okay, thanks a lot. I look forward to see it next time.
Thank you so much. Me too.
Thank you, sir. Thank you, ma'am. Now we are moving towards the next presentation. For the next presentation, I would like to call Mohammed Hassan for the paper title Development of 5G Network Utilizing Spectrum Sharing Techniques.
Good
I request the
afternoon.
presenter to kindly proceed with their presentation.
You can see my
Good
screen.
afternoon, sir. Yes, sir. Your screen is visible to us.
Okay. Now can start.
Yes, sir. You
Hello?
can proceed.
Okay. Greeting for all, and first of all, I thank you to give me this opportunity to present my paper, which is titled Development of 5G Network Utilizing Spectrum Sharing Techniques, presented by Mohammed Hassan. The problem statement. The development of wireless communication has been marked by rapid and advancement, but it's also facing numerous challenges that need to be addressed to continue this growth in innovation in this field. The radio frequency spectrum is finite resources, and with growth demand for wireless service, there is increasing competition for variable spectrum. Development technologies that use spectrum more efficiency, such as cognitive radio and dynamic spectrum access, is a significant challenge. The objective of this work, this study aims to propose a new approach combining with uncooperative cognitive radio network that significantly improve the spectrum efficiency in the downlink non-orthogonal multi-axis NOMA power domain, particularly when integrated with variety of massive multi-input, multi-output MIMO. The methodology was used using the given technique. That main element of the strategy for optimized spectrum efficiency were examined. A logarithmic method are used. Software methodology was used to design and implementation the proposed system, and the final result will compare with other results and get the improvement. In production, 5G introduced a range of advanced features that enhance wireless communication system compared to the previous generation. One of the goals of 5G significantly high data rate with potential peak speed of up to 10 gigabit per second with lowest as 1 millisecond latency. It is expected that multi-access technology such as NOMA will be developed to address these challenges. This system can effectively handle a range number of users with less complexity and lower resource use compared to the existing multi-access solution. The characteristic of NOMA, such as low access latency, user fairness, balance, denser communication, and high spectrum efficiency, have led to pursuit of this wire spray implementation. Other potential methods for managing a spectrum that provide opportunistic of demand communication and thereby solving the bandwidth problem in other licensed wireless communication network is cognitive radio technology. There are two distinct user kinds in cognitive radio-based network: main user or primary user and secondary user. The latter of which do not posing to a valid license. Opportunistic usage of of the license spectrum is the goal of the secondary user who are competing with a primary user for spectrum access. Accordingly, cognitive radio technology is expected to play a significant role in building wireless networks and satisfies the incredible fast requirement of future wireless network. Cognitive radio may be adjusted to optimize spectrum utilizing while safeguard primary user performance, and it's also cognize of an adaptive to the operation radio environment. Various methods have been identified in early research to alleviate the impact of multipass propagation. This process entailed to use a substantial quantity of antenna and the convenience of multi-signal between the transmit and receiving entities. There is deploying of MIMO communication with a wireless network has the potential to enhance the network capacity and spectrum efficiency. The most important finding from our study and motivation, the innovative aspect of study consider less the utilizing of advanced technology and technique to improve the spectrum efficiency in 5G network. Furthermore, to enhance the spectrum efficiency, the study proposed integrated of NOMA with uncooperative cognitive radio. An advantage of this technology convenience is enhanced communication. Additionally, the utilize MIMO and integrated part of strategy aims to optimize the spectrum efficiency to accomplish this in important increase the spectrum efficiency of the network antenna. The investigation of the recommended strategy involved quantitative examination of different network in the topologies and size. After read this, the way in which this technique enhance spectrum efficiency become more evident. The study considers the effect of successive interference cancellation, relay fading, and unstable channel in performance, enhancing the authorize of the evaluation. The system model, we have 6 users. The first user is a far user, and the user 6 is near user. As the principle of NOMA, user 1 or the far user will dedicate it power location, high power location, and user 6 is the near user will dedicate it low power. We have four scenarios. This is the first one. After that, we integrated with uncooperative cognitive radio. After that, the two system model will integrate it or will combining with massive MIMO, variety massive MIMO. This is a parameter, transfer power, bandwidth, and distance. The result, as you can see, we have 6 users. The first user is high power, but is far from base station. The near user is user 6, has better spectral efficiency. We get 4.55 bit per second overhead at transfer power is 30 transfer power in milli dB. When combination with uncooperative cognitive radio, we can see that the improve of all the 6 users will improve, spectrum efficiency will improve, and the improve of the best user, user 6, we get 9.5% when compared to the previous result. Here we get the best user only, the best user, user 6, and get the spectrum of efficiency of for NOMA in three scenario when combination is 8 by 8 and 16 by 16 and 32 by 32 massive MIMO. The performance will increase for this for 6 user is 32.8% and 53% and 71% when compared to the conventional NOMA. And here when we use when we use the uncooperative cognitive radio with NOMA and combination with mass MIMO, Also for user 6, also the improvement for user 6 is 35%, 55, and 73 when compared to uncooperative cognitive radio norm. The conclusion, the result of the unique NOMA system show considerable improvement in spectral efficient performance when pairing with proposer approach. The creative influence of the proposer concept stems from the ability to successfully solve the existing and future issue in wireless communication network by creating by increasing spectral efficiency and utilize cutting-edge technology to achieve optimal performance. To improve the comprehensive in future work, the proposed system will combine with artificial intelligence. Thank you for listening.
Thank you, sir. Session chairs, do you have any questions, sir and ma'am? Ma'am? Sir?
Oh yeah, for me, I don't have, yeah, for this one.
Okay, sir. Now we are moving towards the next presentation. For the next presentation, I would like to call Salvatore Valla for the paper title From Novice to Expert on the Job Learning of Autonomous LLM Agents in White Collar Labor. I request the presenter to kindly proceed with their presentation.
Thank you. Thank you very much. And good afternoon, everyone. I'm pleased to welcome you to our presentation titled From Novice to Expert, the on-the-job learning of autonomous LLM agents in white-collar labor. My name is Salvatore Valla. I'm a PhD student at Toronto Metropolitan University, and today I'll be discussing our research in how we might leverage generative AI and specifically large language models to assist white-collar professionals in their work. Our study explores the concept of AI agents that learn on the job, much like human professionals. They don't just work with pre-programmed knowledge, they acquire new skills, adapt to different tasks, and evolve from novices to experts over time. And this is what humans have to do on the job, and what's called on-the-job learning, to learn about clients, how they want to be treated, and especially in the case of client-facing jobs. Let's start by outlining our main goal. In this project, we explored how generative AI can be used to augment the work of white-collar professionals. And specifically, we focused on autonomous LLM agents and their ability to improve through on-the-job learning. When a new employee starts at a company, they are given some manuals on how to do the job, they're given some tools, and of course, they bring the knowledge they already have. All of these things don't make them immediately effective. The process documents they use may be out of date. The manuals that they have don't capture all the details of what needs to be done. And there are soft skills that need to be learned, especially in dealing with clients and coworkers. So the question guiding our research was, how might these AI agents evolve from junior roles? Can we create a junior role to a senior, more expert role in a given profession? And we chose, you'll see, we chose a wealth advisor here because it interacts with clients and needs to be able to learn on the job in various dimensions. And so this is particularly important in sectors where knowledge acquisition, client interaction, decision-making skills are essential. What we envision is a future where AI doesn't just automate tasks, it becomes an integral part of the workforce, a personal assistant or augmentation, learning from experience and continuously refining its performance, much like human employees do. And this research focused on the technology of generative AI, the actual tools. And we do appreciate the fact that there are both people issues, skills, for example, and process changes that need to be made in addition to the technology tools that need to be brought to make an actual real-life implementation a success. A tool is a component of what would be needed for a real-life implementation, but not only. In a former role, I was in a business building software tools. We had a tool saying there that a fool with a tool is still a fool. So we need more than tools. So tools are important, but we also need people and process changes as well. To provide more context, our research again focusing on autonomous LLM agents, which function as digital labor in various white-collar professions. And we looked at 3 different white-collar professions. What I'll talk about here mainly is the wealth advisor. And these agents powered by models like GPT-4 are capable not only of retrieving information, but also learning through interaction. We use Bloom's taxonomy as a framework to measure their development. And Bloom's taxonomy has 6 levels of learning: remembering, understanding, applying, analyzing, evaluating, and creating. And so we created a set of simulated scenarios, and we observed how the agents could gather knowledge from client interactions, analyzing the information and apply it to future interactions. And essentially, we wanted to be able to mimic human professionals and how they learn from experience and improve over time. And we make the full transcript of the experiments available in a GitHub repository as well. And since publishing the paper, we've now created a more complete bespoke framework for creating generative AI agents for multiple white-collar roles, and we call this Corpia. So it's a way to be able to methodically be able to create these agents. Now I'll explain a bit about the methodology we use. We designed an experiment where an autonomous LLM agent took the role of a wealth financial advisor. And this role involves deep expertise in areas like financial planning, tax strategy, and investment management. The AI agent was introduced to a fictional client and participated in a series of discussions, gaining new information about the client's financial situation, preferences, and goals with each interaction. We had programmed a set of listening cues. In this case, it was the client's name. So every time a client name was mentioned, we wanted the agent to be able to remember more details about the client. Whether the client was dissatisfied, so we wanted to be able to have the agent introspect and understand whether it should behave differently in terms of the client interaction or how the client wants to be treated, and customer information in general. The agent captures this information, stores it for later use. And this is, again, what a white-collar professional would do. We tested the agent's learning using a set of questions based on Bloom's taxonomy. These questions allowed us to assess how the agent could not only recall facts, but also apply its knowledge to solve complex problems, make judgments, and even create custom financial plans for the client. We focused this study, and we have others in the transcripts, on a wealth financial advisor. A wealth financial advisor typically works for a bank and works with clients and their financial needs, which can be everything from investments to insurance, to estate planning to tax planning. And clients are often high net worth individuals or families. And the role is a comprehensive role, with the best client advisors are the ones who are trusted partners with the client. And this wealth advisor role was chosen because it requires a balance of hard skills, such as financial analysis, risk management, and soft skills like client communication and trust building. We find the key competencies that the AI would need to master: knowledge, expertise in areas such as investment strategies, tax planning, estate management, market trends, experience, the ability to draw from a history of successfully managing high net worth portfolios, so some amount of memory, and being able to, and a set of skills, proficiency in financial modeling, strategic planning, and negotiation. And we equip the client with a set of tools similar to what a human advisor would also have. The agent's job was to learn from its interactions and continually refine its ability to serve the client. This, again, is the on-the-job learning that a human wealth advisor would go through to refine its knowledge and approach and how to best serve the client. We also had a personality you'll see here as well, because we wanted that it matters. In the case of a financial wealth advisor, you want someone who is detail-oriented, excellent communicator, and also projects confidence to the client. On the framework that we used, this is how we structured the client's learning and interactions. Several key components. One is a knowledge component. Starts with a set of foundational knowledge specific to the role. In our case, as a wealth financial advisor, this includes areas both declarative knowledge, which is the what about the role, the knowledge about the financial instruments, for example, and procedural knowledge. This is the how about the role, which is how the role is done, how to deal with clients, for example. We had a set of experience, and so we wanted to make sure that it gains on-the-job experience similar to how a human would, includes listening for explicit feedback, the ability to be able to reflect upon its performance, be able to get mentoring advice and episodic memory on particularly important past events, especially if the client was disappointed. We wanted it to remember that and formulate a strategy to never, ever disappoint the customer again. The tools, we equipped the tools with a set of digital tools that it could use here, and personality and soft skills. So again, we gave it a personality profile, make it more empathetic, trustworthy, and also confident as it talks to the client. Because in an area like wealth management, in a lot of white-collar roles, trust and those soft skills are paramount. So this framework combining knowledge, experience, skills, and tools and personality allows the AI agent to move beyond simple task evolution to more expert assistant. And over time, as the agent accumulates more experiences, it becomes more proficient and answers the client understands the client's profile and also understands how the client wants to be treated over time. Now, let's move on to Bloom's taxonomy, which serves as the backbone for our evaluation framework. Bloom's taxonomy classifies learning into 6 stages, ranging from simple recall to advanced problem solving and creation. These are, remembering, can the AI recall basic facts and details? Understanding, can it interpret and explain the information that's gathered? Applying, is the AI able to use its knowledge in practical situations like advising a client? Analyzing, can it differentiate between different pieces of information, categorize them, and find patterns? Evaluating, is it able to make this judgments, critique strategies, or assess different financial scenarios? And creating, can the AI go beyond what's been taught and generate new ideas, new content, such as custom financial plans for a client that it has evolved in learning about? And so we tested the agent on all of these levels here. We found that the AI agent performed well across all levels of Bloom's taxonomy. It was able to recall information about the client, understand their financial goals. More importantly, it could apply its knowledge to offer advice, analyze various investment options, and even create a full financial strategy tailored to the client's needs. The finding is significant because it suggests that AI agents can evolve beyond just basic automation. They can learn and adapt, taking on more complex decision-oriented tasks over time. This opens up new possibilities for how AI might be used in professional settings, not just as a tool, but as a partner to professional workers. And we're even now looking at a level of providing ongoing mentorship to a white-collar worker. So not only answer the question, but also provide background advice to the human worker on an ongoing basis to make the human worker better over time. So AI's ability to continually learn, retain knowledge makes it a valuable resource in roles traditionally thought to require a high degree of human expertise. Though this, again, I have to admit, this was a very simple case with a limited set of tasks, and there's lots of future work to be able to do. So just in terms of where this work is heading, our next steps include defining additional roles for AI agents. And as I said, we've already created a framework to be able to create any number of AI white-collar roles, have incorporated the ability to be able to listen dynamically for any number of cues. We have the ability to be able to create teammates. So if a given problem requires a subject matter expert that's not the agent, it can call to another
Sorry to
agent with that
interrupt, sir,
subject matter.
but you have 2 minutes to conclude.
Okay, thank you. AI can learn a job just like we do with the right framework. It can grow into now the invaluable asset. Required changes in how we think about training, collaboration, skill development in the workplace. I'd like to thank you for your attention. I'm happy to to take any questions you might have.
Thank you, sir. I request session chair, sir. Do you have any questions?
Yes, I have. For the data that you use for the calculation, you use the AI or the outside one for calculating.
This so we used GPT-4 mainly in this.
No, I just want you to be aware that this is not just a question. Be aware that GPT has a problem in calculating. So sometimes they do the missing calculations for many times, especially the reasoning. So please be aware on this one. And second one is the results. Sometimes they just come by themselves. Like if you let them do some research, the reference they did is not real. They just come from nowhere, so like that. Just be aware, but your work is great.
That's right. That's right. So we provided it a set of tools. So if it needed analytical tools, it would go to the definitive tools, not use things like calculators itself. And we also provided grounded knowledge. So both the declarative knowledge and procedural knowledge were grounded knowledge in documents versus the model making it up itself.
Yeah. So in the future, if you want to process on this one, make sure that you do the calculation outside first, or you make sure that you do the correct calculation before sending in. But GPT is very good in the reasoning one. If you let them do the reasonings or getting back, because now they increase the working memory quite a lot, so they can recall it for very long, like that.
Yep. Thank you.
Thank you, sir, for such good suggestions. Now we are moving towards the next presentation. For the next presentation, I would like to call Nibod Saf for the paper title, Natural Language Processing for Insider Threat Email Detection, Optimized by Modified. I request the presenter to kindly proceed with their presentation.
Greetings, respected chair, and to all the other participants. Unfortunately, Nebojša won't be able to present this paper. My name is Alexander Petrovic, and I will be presenting on the behalf of him and the research team behind this paper. Just give me 1 second to share my screen.
Okay. Yes, sir, your screen is visible to us.
Okay, thank you very much. Okay, the paper I'm presenting today is titled Natural Language Processing for Insider Threat Email Detection Optimized by Modified Meta-Heuristics. Below you can find the names of the co-authors of this paper and the people that have worked on this paper. Some of them have been already introduced, so I will just skip this part and move on to the paper itself. To shortly present what is the point of the paper is insider threat detection, and this can happen very easily through malicious emails, which are still one of the most used mediums for doing this type of an attack, and large corporations, companies still battle this issue with their workers, as it is very hard to avoid clicking on on one of the spam emails, especially if you're not from our field of work. So what did we attempt to do in this paper is that we used a natural language processing technique to extract better meaning from the text itself, and to detect potential patterns that lead to attacks in companies. Our main predictor was the extreme gradient boosting algorithm, which was optimized by one of the meta-heuristics algorithms, which have proven quite well in this for this particular scenario, where they're used as a technique that optimizes the hyperparameters of another technique. Okay, so a little bit more on the problem itself. As I've already mentioned, this is still a very, very common problem today, especially as the malicious emails can easily blend in, and with very little information, they can be made to look like they have been sent from inside the firm, and so on. In these cases, sometimes we really can't blame the person that actually opened that email, because they are getting very advanced in this type of fraud, to say. Considering the scope of the attack, which can be achieved if the attacker gains any sort of access to the company, it can depend, of course, on the scenario and the attacker's motives. But the most likely motives are the destruction of content, of data, which is very harmful and can lead to very high financial losses, as well as blackmail and data leaks, which are all very harmful behaviors. Here we use machine learning, which has proven to be a very prominent technique for detecting patterns, and especially when we're dealing with natural language, we can it is just that there are a lot of patterns in the way that we speak, the way we write, and this makes these techniques especially suitable for this type of problem. However, this is considered an MP hard problem, which makes it not suitable to be solved by the trial and error, and this is also one of the reasons why artificial intelligence is needed to be used in this sort of scenario. So what have we proposed? Firstly, the NLP technique that we used is called the bidirectional encoder representation from transformers, abbreviated BERT. And as I already mentioned, this technique is used to extract the context of the word and analyze the words around it to figure out what the author wanted to say in that type of sentence. The XGBoost is the main predictor, and the optimizer that has been used is the hybrid swarm metaheuristic, which is based on the veil optimization algorithm. We have used another metaheuristic, as it says, it is hybrid. So the other metaheuristic algorithm that has been used is called the Firefly algorithm, but more on that in following slides. And furthermore, this is also an MP-hard problem. So the BERT technique, it is based on the attention mechanism, and it is used to find representations of sentences and their symbolic meanings by analyzing the text. And what is interesting about this technique is that it can shift its focus from the input data and the data currently at hand, and by doing so, it can provide much clearer context of those words. And the basic principle on which it works, besides the attention mechanism, is the analysis of adjacent words to the words at hand. So how does it work? It uses a masked language model and picks a word at random, which is masked from the predictor. And this word is to be predicted, and its meaning based on the adjacency of all the other words around it. The most common use cases are summarization, querying, and text classification. Just a quick slide on the XG boost, as it is one of the very commonly used techniques due to its performance. It is based on decision tree models, many of decision tree models, which are merged into an ensemble of decision trees to provide the strong predictor. The basic form of its objective function is given here with the loss function and the regularization parameter following. More details on this you can find in the paper and the original cited work of the XG boost. Regarding the whale optimization algorithm, it is inspired by the hunting behavior in humpback whales, and this behavior is called bubble net hunting, in which the whale spirals towards the surface of the water and releases bubbles, so it can actually trap schools of smaller fish in it and just pick them up as it goes up to the surface. So this is the most basic principle. The details on the whale optimization algorithm have had to be excluded from this presentation because there is quite a lot of mathematical formulas behind it. So I would kindly refer the participants to read our paper and find more information about it. And the first modification that we have applied to this original solution is the quasi-reflexive learning initialization strategy, which is provided below. And the idea is to initialize half of the population with the original initialization strategy from the whale optimization algorithm, and the other half is initialized through this equation, which is given below, and in the equation we have the lower and upper boundaries given, and A represents a randomization factor, which is used for scaling of this of the population that is initialized through this form. Furthermore, as I mentioned, we have the Firefly algorithm, which has been hybridized with this WOA algorithm, and here we have it a little bit complicated formula of its search. And the basic principle of the Firefly algorithm is that it works on the principle that fireflies emit a light, and the intensity of this light and the distance from each firefly is used to find the best solution as a meta-heuristic method. So the intensity of this is beta, and the alpha is a scaling factor as well in this equation. Below you can see the pseudocode of the proposed solution, and as I mentioned already, we initialized the half of the population with the original strategy and the other half with the QRL, and based on the random factor psi, we choose either the Firefly search or the WOA search to be applied. All right, moving on to the experimental setup. The data set that was used is the dataset insider threat data set from the Carnegie Mellon University, and this data set has a lot of different scenarios, and this work focuses on scenario 4.2, where as it was already mentioned, the emphasis is on patterns leading to harmful behaviors, so text patterns in emails. However, this data set, or rather this part of the much larger data set, is quite imbalanced. So random samples were chosen in the ratio 10:1 of normal against malicious samples, ending up in the 70% of the data being used for training and 30% for testing. Other experimental set of parameters include 30 independent runs, the end below, you can see the boundaries for the XGBoost parameters that were set. So within these boundaries, the meta-heuristic algorithm was optimizing XGBoost. Okay, and moving on to the results, the proposed solution, the XGHAWOA, in all cases achieves almost all cases, sorry to rephrase, achieves the best possible solution, which is equal to the other strong optimizers, which are given below. And keep in mind that these algorithms are considered one of the best optimizers and predictors that are used. So having equal performance as these algorithms is much of a success. However, the real contribution is that the original Whale optimization algorithm achieves worse results than the proposed solution. So by doing so, the proposed solution, the improvement in the proposed solution is verified. Notable is the performance of the PSO, the particle swarm optimization algorithm, that has till this day proven to be one of the strongest performing algorithms. And while sometimes it doesn't have the best precision, it can have it usually has the most stability according to its standard deviation and variance parameters. Since I mentioned already that the data set was in the beginning imbalanced, we have also applied the Cohen-Kappas as an indicator function to further validate the performance, where we can see a slight difference between the PSO and the RSA here, having the best mean and median, but PSO still remains to be the most stable solution. Okay, and on this slide, you can see the parameters which were selected by each of the meta-heuristic optimizers. So once again, we're looking at XGBoost hyperparameters as the main predictor, which were selected by the meta-heuristics that you can see in the column 1. All right, to conclude, the potential of artificial intelligence is still to be achieved in these scenarios, as many others, of course. But the idea that we're still managing to improve existing solutions is quite motivating to explore all the other possible solutions. Hybridization is still a prominent technique, and by using algorithms that are strong optimizers, such as the Firefly algorithm, even trivial changes like the random phases between the WOA search and the FA search still quite improve the performance, meaning that there is a lot of space for more sophisticated hybridizations and modifications of the algorithms, leading to a more powerful algorithm. One thing I forgot to mention during the previous slides is that due to the no free lunch theorem, we have to explore all these combinations of algorithms, all the possible combinations of different solutions to achieve the best one, because the no free lunch theorem, just putting it shortly, states that no single solution performs equally well for all problems. So when we have a different scenario, for example, if we had a healthcare scenario and the data on healthcare, probably the performance of the techniques that we used would not be the same, and different ones would be better than in this scenario. And of course, cybersecurity is one of the fields that is actually AI is very crucial to the improvement of the cybersecurity, as it is a very fast expanding field in terms of the creativity of attackers that always figure out new solutions. So by creating powerful predictors and pattern recognizers, we can really help alleviate this issue. Thank you very much. That would be all from my presentation.
Thank you, sir. Sir, do you have any questions? Okay. Sir is not having any questions. So let's move toward the next presentation. For the next presentation, I would like to call Anton for the paper title, The Influence of Knowledge Transfer on Change Management in the Creative Industries in Indonesia. I request the presenter to kindly proceed with their presentation.
Okay, Mr. Thank you. I will start my presentation. My title research is The Influence of Knowledge Transfer on Change Management in the Creative Industry is in Indonesia. Based on Presidential Regulation Indonesia number 8/2008, creative industry subsector is advertising, architecture, art, good market, craft, design, fashion, video, film, animation, photography, games, music, perform arts, publication or printing, software, television or radio, and research and development. I think creative industry Indonesia give a good contribution every year. You can see the graphic. And Hopkins says creative industry built from creativity and intellectual. It's mean intellectual. It's mean intellectual basis is knowledge, and knowledge is fundamental research organization. Liu et al. 2020. And Pinati says knowledge can create change management. So based on the research finding, we arrange main variable like knowledge transfer and change management, and we add variable such IT atau or information technology and information system. Research gap and novelty is just one research from Yan and Sang. They use qualitative research. Meanwhile, our research use quantitative research. And research recommendation from Dunslap and Iqbal. This is my research model. And this is my hypothesis. There is an influence between information technology and knowledge transfer. Hypothesis 2, there is an influence between information technology and change management. Hypothesis 3, there is an influence between information system and knowledge transfer. Hypothesis 4 is there is an influence between information system and change management. And hypothesis 5 is there is an influence between knowledge transfer and change management. This is my model testing, and this is the result. From the result, T square is 30.393. That is less than 35.172. P value is 0.138. probability value greater than 0.05. The output value for GFI, RGFI, and TLI value are greater than 0.9, and the output value J-min is less than 2, RMSAR less than 0.0x, and the value of AEC and EJFI less than saturated and independence model. From all the test result output analyzed, it can be stated that the model has met the model fit criteria. This is my direct effect test. From the table, information technology has no effect on knowledge transfer. Information system have a significant influence on knowledge transfer. Individual knowledge transfer and group knowledge transfer have significant influence on knowledge transfer. Knowledge transfer has effect on change management, and information technology and information system has no effect on change management. This is my conclusion and recommendation. It can conclude that only the information system is variable that indirect influence to change management through knowledge transfer. And through the information system built by organization, member can access this knowledge gain for discussion with one individual or with one division or group. Referring to data tabulation, there are two important points related to information system. The one is information system will must be easy to use, and the two, the information system used by organization must have an important function in driving the operation of an organization. And it is important for a company to be able to ensure knowledge transfer occur. Organization as knowledge manager need to ensure that knowledge share in well absorbed by recipient, maybe with form or quiz. When knowledge can be absorbed well by individual or group, it can be ensured that learning, increased skill, and innovation discoveries have occurred, which indicate the achievement of change management. And in relation to issue related to the creative industry, this will indicate that human resource constraints can be overcome and companies can overcome the decline through innovation. In the end, the company is able to achieve competitive advance as a strength to compete with the other companies. That my research. Thank you, Mr.
Thank you, sir. I request session chair, sir. Do you have any questions? I request session chair, sir. Do they have any questions? Okay, sir. Sir is not having any questions, so we are moving towards the closing remark. So I sincerely thank all our authors for the excellent presentation and contribution in this session, and all participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support during the third version and all the previous two versions of the conference. We will be happy to have you in the fourth version in 2025. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of ISBM 2024. I also thank our session chair, Dr. Pilin, for sharing the session. Sir, this is a token of appreciation from the team of ISBM 2024 and Global Knowledge Research Foundation and partners. Sir, kindly address our participants.
Hi, yeah, you want me to talk about what? Sorry.
Thank you, sir. Now, I would love to extend my gratitude towards our next session chair, Dr. Namisha, for chairing the session. Ma'am, this is the token of appreciation to the chair on behalf of team ISBM 2024 and Global Knowledge Research Foundation and partners. Thank you, ma'am and sir, for your valuable presence and time. I request everyone to kindly turn on their cameras for a quick virtual snapshot. Thank you, sir.
Okay.
I request everyone to kindly turn on their cameras for a quick virtual snapshot of the conference. It's very great to meet you all. Hope we will meet in future too. Thank you. Have a great day.
Okay.
Bye-bye. Thank you, sir.